Hello, everyone. In this video, we'll start chapter 24. The approach we adopted in this book for data structures is to first, we introduce how to use data structures. In chapter 20, we introduced lists, stacks, queues, and priority queues. In chapter 22, we introduced the sets and the maps. These two chapters cover the use of the data structures in the Java API. In chapter 23, we introduced the analysis of the algorithm efficiency and design efficient algorithms using appropriate data structures. In chapter 23, we introduced how to design efficient algorithms for solving problems. Now we will turn our attention to implementing data structures. In this chapter, we will see how the data structures, lists, stacks, queues, and priority queues are implemented. Through the implementation, we will gain deeper understanding of the data structures. We will know why one data structure is more appropriate for certain applications. You have many data structures to choose for storing, organizing, and manipulating data. Use the appropriate one, and that is, you can see it from implementation and which one is more efficient for certain applications. We're going to look at the lists first. A list is a popular data structure to store data in sequential order. There's a notion of index for a list. For example, you have a list of students, a list of available rooms, a list of cities. You can maintain the elements in a list in certain order. And you can also retrieve the element, the first one, the last one, the middle one, insert new elements into a specific index. The common operations on a list are usually the following: retrieve an element from this list, insert a new element to this list, delete an element from this list, find how many elements are in this list, find if an element is in this list, find if this list is empty. These are the common operations. We're going to design our data structure now. We will design in a way that is very close to the Java API. Two concrete list classes are presented in the Java API: the array list and linked list. The array list is implemented using array. The linked list is implemented using a linked list. So you have all the elements are linked together, and each element is actually put into a node, and all the nodes are linked together. All of this the common operations are defined in this my list. We're going to define it this way now. The we're going to call this array list my list in the implementation. And this is my linked list to distinguish from the Java API, array list, and linked list. And this is my list, and we're going to make it part of the Java API now to make my list a sub-interface of the collection interface. It also extends the iterable interface. Now this is my list interface. It is sub-interface from the collection interface. It has all the essential methods. Add. Now everything already in the collection interface is automatically inherited, so it's not listed here. Additionally, we have this add element to a specific index and get the element from this index. Index of is to find out if this element is in the list and which index is the first one. Match for this element. Last index of is to find this element starting from the end. Remove the element at the given index, set the element at this index. You're going to override the methods add is empty, remove contains all, add all, remove all, retain all to array, and to array methods defined in the collection. This is my list. In the next video, we'll look at the implementation of the array list. See you on the next video.